Hi dear students, welcome again to our YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to discuss chapter Differential Equation. So now let us try to understand the concept and then we are going to take up the problems I mean to say, and here we have got for 7 plus marks for annual board examination. So see here, what is equation? Okay, differential equation. Before that, just observe some of the equation which I am writing here. For example, x minus 7 is equal to 0. It's very light. One more. Yeah, this is better. X square minus x plus 1 is equal to 0. One more. X plus y is equal to 8. Then 2x minus y is equal to 9. Okay, one more. Let's suppose x square plus cos x is equal to 0. This all are equation. So this is linear equation because highest degree is 1. This is quadratic equation because highest degree is 2. This is system of linear equation. System, I said, more than one equation, and it is linear because the degree of each of this is what? 1, the highest power, and it's not a quadratic. This is a transcendental equation. We call it transcendental equation. Now here none of them are differential equation. Why? It doesn't involve derivative. Now what is differential equation? So coming to the definition of differential equation, any equation involving derivative or derivatives of the dependent variable with respect to independent variable or variables. Any equation involving what? Derivative of whom? Dependent variable. With respect to whom? Independent variable. So as you know, that throughout our context, we have got any function of the form y equal to f of x. X is the independent variable. X is the independent variable, whereas y or f of x is what? Dependent variable. So now this is also not a differential equation, it's just a function. Now see, if I have got derivative of this y with respect to x plus 7y is equal to cos x, this is the differential equation. Now here I would like to also comment one more thing. Here I have just commented derivative or derivatives, nothing but it can be more than one derivative, no problem, but with respect to independent variable or variables. So here, since y is in terms of x, we have got only one independent variable, that is x. It may also happen that we may have more than one independent variable. Then that's the reason I commented with respect to what? Independent variable or variables. Mean to say, just see carefully. This particular differential equation is having only one dependent variable, and this is depending on x. This we call ordinary differential equation. Ordinary differential equation. Now what is ordinary differential equation? Any equation involving derivative with respect to only one independent variable. Whereas you see here, and in short we call this as ODE, ordinary differential equation. Okay, first point. Second point, let us suppose that, okay, now in this regard y is depending on only one independent variable x. Now you see, if I have got a function u and this u is depending more than one independent variable, let us suppose x also, y also. Now when I want to differentiate, see the way of heading. This is derivative, ordinary differential equation, derivative of y with respect to x, but this is partial derivative of u with respect to x plus let us say some 7 partial derivative of u with respect to y is equal to 8x plus 7. This is called partial differential equation, where the function u is depending on two independent variables, that is x and y. That's why you can see now an equation involving derivative or derivatives. Here also no, I can have one more derivative. For example, here itself no, I can have second order derivative also, no problem. So it can have one derivative or more than one derivative, no problem. But the difference comes here no, with respect of the dependent variable with respect to independent variable. When I'm saying independent variable, it means to say ordinary differential equation, nothing but this, only one independent variable, and you can see derivative is with respect to x, nothing but only one independent variable. But it may also happen that more than one independent variable also variables are given. So since u is a function of both independent variable x and y, so you have got dou u by dou x plus dou u by dou y, where both x and y are independent variable. This we call partial differential equation. What we call partial differential equation, and in short we call this PDE. Now coming to our syllabus. Now PDE, when I'm saying no, see P first letter of the word P, partial differential equation, first letter of the word ODE, ordinary differential equation. Now here we should also understand that coming to our syllabus, that will be PUC, CET or JEE, we are not going to have this, okay? But in textbook also there is just a discussion without an example. I thought I will quote it. Now I'll focus only on ordinary differential equation. Henceforth, even if I won't use the word ordinary differential equation, it's understood that it is about differential equation, nothing but ordinary differential equation only. Whether I specify ordinary differential, whether I specify the word ordinary or not, it's only about ordinary differential equation. Coming to this year second year as well as CET as well as JEE Mains. Kindly make it. Dear students, having understood definition of differential equation, now let us try to move on the next concept on differential equation, order and degree of differential equation. Now what is order of differential equation? Let us try to understand order of DE. I will write for differential equation. Order of differential equation is defined as highest derivative. It is defined as highest derivative in the given differential equation. In the given differential equation. For example, let us suppose that we have been given one differential equation now what is the highest derivative in the given differential equation. In this, which are the derivative we have got? This is the first order derivative, differentiated only once, but power is 10, multiplying 10 times. This is only second order, differentiated only second times, and the 2 times it is differentiated, and here there is no derivative involved. So among the two, this is differentiated maximum number of times, so this will decide the order, and here the order of differential equation is 2. Okay, whereas degree of differential equation is defined. I'm using one word, define. Before I go to degree of differential equation, let's go to polynomials. Polynomials, to have better clarity. Polynomials. What is polynomial? Any expression of the form P of x is equal to a naught plus a1x plus a2x square plus a3x cube plus dot 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 a n x power n. If at all I said it's a polynomial of degree n, then x power n multiple, that is a n, should not be equal to 0, and a naught, a1, a2, a3 up to a n, nothing but all a i's should be a real number, and this power n you can see no, start from here 1 2 3 4, but I can say here x power 0, nothing but should be a non-negative integer, nothing but whole number also I can say. So you can see here there is no any trigonometric function involved, nor log function, nor exponential function. Let I just give still more clarity. Just see. I am still talking about polynomial without derivative. See some examples. We have to understand whether it's a polynomial or not. If it is a polynomial, only then we are going to talk about the degree. What is degree? Highest power of the given polynomial. Now see first example, if I give you x square plus x minus 7 is equal to 0. This is a polynomial. So since I get equal to this, it's a quadratic equation. So I will just talk about polynomial. Okay, fine. Equation, let it be there. No problem. This is a quadratic equation. Why I said quadratic? Highest power is 2. And this is a polynomial. Okay. Therefore, because of this, degree is what? 2. Okay. This, since it's a polynomial in terms of x, I was able to say. Okay. Now see this carefully. But if I give something like this, same, see carefully, what do you say? Is it a polynomial? Sir, we have got 1 by root 2. I said here, constants can be any real number. So there's no problem. Only the thing is power should be a whole number. Yeah, power is a whole number, 2 and 1 here. Again, this is a polynomial, same as this. So both are what? Polynomial. Polynomial. Therefore, again for this degree is what? 2 only. Again, if I take one more equation, see this carefully. Is this a polynomial? Many will see this cosine term and they'll be in doubt. Sir, it's not a polynomial because cosine it came and here there's no trigonometric function. That's the reason I took this example. This is again a polynomial. Reason. See, cos purpose is what 1 by root 2. What I mean to say, just presence of cosine or trigonometric functions or log function or exponential function is not important. Who is sitting inside them? Is it the same variable x? See here, this is a polynomial in terms of x because cosine don't contain x term there. Okay, that's the reason. Again, this is a polynomial of degree 2 only. Okay, whereas if I give you something like this, now this is not a polynomial in terms of x. Okay, as x is contained in trigonometric function, therefore I can just say is not a polynomial in terms of x. Let I give you the reason why it is so. Polynomial, when we talk about degree, it is the highest power. Cosine, no, when we expand, we will get x minus x cubed by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial and so on. It's an infinite series. Since it's an infinite series and the cos x is present here, the degree, since it's an infinite series, it will never end. So we cannot talk about the highest power. Nothing but degree is not defined for this term in this entire equation. We cannot define. Thus the result is not a polynomial in terms of x. Hence degree not defined. Hence degree undefined. Undefined. I hope this is the logic you have understood. Whereas here we cannot expand a constant. Same rule follows here also. Coming to differential equation, the role of x is taken care by derivative. Now if you see here, coming to the degree of differential equation, see cosine is there, yeah fine, but inside it is not derivative. This is case of something like this. Therefore degree is defined. Now what is degree? Degree is defined as highest power of the highest derivative. Highest power of the highest derivative. See in this, which is the highest derivative? This. What's the power of this? No power mentioned, so it is 1. It is not this. That's why I get 10 there. This point is clear. Okay, let's take one more example here on differential equation. If I just give you derivative of y with respect to x plus 7 times of third order derivative plus sine y is equal to 0. Now first, coming to order, there won't be any problem. Order always exists whether derivative is present as an angle or not. Please bother. Okay, of trigonometric function or exponential function, power or log term. Okay, of the log term. Now just here in this, which is the highest derivative? This. So this will give you the order. This is differentiated only what? Once. This is thrice. Okay. So here, see this carefully. Here the order of the differential equation is 3. That I do purposefully. I raise the power to some let's suppose 8. Now what about the degree? First you have to be sure whether it's a polynomial in terms of derivative. See carefully. Yes, it is. Sine is there, but inside sine the angle is not a derivative. Okay, so it's a polynomial in terms of derivative. Therefore the degree will be given by highest power of the highest derivative. You know why I'm saying highest power? First let us complete this. So here the highest power of the highest derivative. This is the highest derivative and the power is what? 1 here. Now why I'm saying repeatedly highest power of the highest derivative? Reason, no, for the same problem, I'll take this as example number 3. For the same problem, no, I will just go for this. See carefully now. The order is 2 because highest derivative is 2. But what about degree? Coming to for this problem, we have same derivative here and here. And here it is differential, means the power of this is only 1 and here it is 8. Now the degree is 8. That's what I said. It is the highest power of the highest derivative. So this is the highest derivative. And who is the highest power? This. Okay, I hope the things are clear. Now let us take one more example to be very specific. See carefully. Fourth one. Now see this. As you know, the other symbol for that is this. Now this is not a polynomial in terms of derivative. Coming to the order, yes, again the order of this differential equation is, this is the third order, highest time differential, this is second order, this is the first order, so order will be 3. But coming to degree will be what? Undefined. Why? This is not a polynomial in terms of derivative. I hope this point is clear. One more example I will give. Same I will take. One small change. Okay, first derivative again. Now what I want to make you understand, again coming to order of differential equation, this is first derivative, this is second derivative, mind it, and this is the first derivative. So this is the highest derivative. Therefore the order of the differential equation will be 2. But this is again not a differential, it's not a polynomial in terms of derivative, as you can see here. You may be thinking inside is with respect to this. No, I mean to say order is defined by second order, this one, this term. So whether here when you come to I repeat again, order of the differential equation is defined by this term, correct? So student will be thinking in this particular case the same here, order was defined by third order and it was present inside the sign, so it is degree is undefined. What I am saying is, it's not only the same term. As soon any other derivative also present, it's not a polynomial. Reason is the same what I said, infinite expansion. So here also you can have infinite expansion. Therefore again what degree will not be what decided. So again here degree is undefined. Degree undefined. I hope this is clear. Fine. So one last problem I will take. See carefully. Coming to this, let us suppose that we have got a differential equation like this. Now, see carefully. I can simplify this as sine of derivative, first derivative is equal to -8, or derivative of y with respect to x is equal to sine inverse of -8. Now, it is a differential equation and it is also a polynomial in terms of derivative. I mean to say, try to simplify. Can you come out of here? It is not a polynomial in terms of derivative. Now it is a polynomial in terms of derivative because inside sine inverse there is no derivative involved. You may question, sir, why you didn't do the same here? See, if I think of solving this two terms should be transposed. Then I'll take sine inverse of both the sides. The sine inverse will contain this two term because this is in the right hand side. So again it will be what? Not a polynomial in terms of derivative. Same thing here also. If I transpose this two term here and then sine inverse, this two term will be inside the sine inverse there. I hope this point is clear. But here, when I'm taking sine inverse both the sides in this step, since it's a constant, yes, now it is a polynomial in terms of derivative. So because of this differential term, so the order of this differential equation is 1 and this is a polynomial in terms of derivative. Therefore, degree is also there, and here the highest power of this is the highest derivative and the power is what? 1. I hope Is this clear? Fine. Similarly, exponential also will be having the same issue. One example, just take here. Seventh. Suppose we have got first derivative is equal to e power some second derivative. Okay, second derivative e double dash. Now this is also not a differential. I mean, this is a differential equation, but not a polynomial in terms of derivative. Therefore, here order is 2 because of this term, but degree is undefined. Okay, degree is undefined. So with this, we are ready for the problems. Kindly make a note. Dear students, having completed the concept, now let us move on to the first problem from the model question paper. Model question paper number 1. As you are aware, this model question paper is issued by KSEAB for your academic year 2025-2026. Question says, question number 18 for 1 mark. If m and n respectively are the order and degree of differential equation 1 plus first derivative whole cube is equal to 7 times of second derivative whole square, then m minus n we have to find. We have to find the value of this, and this is a fill in the blanks question. Coming to solution, see this differential equation carefully. Order. Recall what is order? Highest derivative. Here we have first derivative and here we have second derivative. So because of this term, second derivative, from here it's very clear that order is 2. Highest derivative is 2. This order is not because of this 2. Second time, here you can see now it is differentiated twice and this is differentiated only once. Okay, differentiated only once. Here it is twice. So order is 2 because order means highest derivative in the given differential equation. Then I want degree. Since this is a polynomial in terms of derivative, degree is defined, and degree is power of the highest derivative. Better, highest power of the highest derivative. Okay, so here see carefully, this is the highest derivative and what's the power here? 2. So degree is also 2. In the question, for order they have taken m, so yeah, this is m, and for degree they have taken n. Okay, na? So now they want m minus n. So m minus n is equal to 2 minus 2, that will be 0. So our answer for this is 0. Okay, kindly make a note. Dear students, now let us move on to the next concept, general solution and particular solution of a differential equation. So general and particular solutions of a differential equation. Let us try to understand this in a very elementary level. See, if I consider an equation, for example, let us suppose a quadratic equation, x squared minus 1 equal to 0. What will be the solution of this? First, what do you mean by solution? Any number satisfying this equation, correct? No? That we call solution or the root. So here, if I just solve for this, I will get x square is equal to 1 if I solve for x, or x is equal to plus or minus square root of 1, or x is equal to plus or minus 1. So this plus or minus 1 are real numbers. So if I substitute x equal to plus or minus 1 in equation number 1 here, it will definitely satisfy. As you can see here, for example, let's substitute here x equal to 1 in equation number 1. This will give us 1 square minus 1 is equal to, you can see, what is 1 square? 1 minus 1. We are getting the right hand side 0. Similarly, put x is equal to minus 1 in equation number 1. So put here minus 1 square minus 1 is equal to 1 minus 1 answer is what? 0. But you can see that other than these two number, whichever number you take and substitute here, we are not going to get the right hand side 0. Nothing but those are not the solution for this quadratic equation. For example, let us say we'll take x is equal to some 2. So put in equation number 1, we will get 2 square minus 1, nothing but 3. Okay, 2 square is 4. I thought right directly fine. 4 minus 1, nothing but 3. 3 is never equal to 0. Therefore, this is not a solution. X is equal to 2 is not a solution. So not only this number, it can be any number. You take other than this two number, x equal to 1 and x equal to minus 1. This will not have any other root than this. Okay. So similarly, if I take one more, as you can see, degree is 2 for this equation, x square minus 1 equal to 0. Therefore, we have only two roots. Now, if you take some other, let us suppose, sine x minus cos x is equal to 0. This is also one equation. And what could be the root of this? One of the root of this will be x is equal to pi by 4. Sine pi by 4, 1 by root 2, cos pi by 4, 1 by root 2. Let's see here, if I put in equation number 2, what we are going to have? Sine pi by 4 minus cos pi by 4. Now, sine pi by 4 will be 1 by root 2 minus cos pi by 4 will be 1 by root 2. Since signs are opposite, I can cancel them, as will be what? 0. This is one of the root. Okay, so general root will be n pi plus, general solution of this will be, I'm not discussing how it is, etc. That will be the beyond the scope of our present topic, differential equation. But anyway, this will be the general solution where n is integer. Now, having this thing understood, see carefully both the equation. Let it be this equation where we have both left and right hand side, and when we say a solution, for example, is equal to pi by 4, it should satisfy the given equation. Nothing but whatever we have got in the right hand side, we should obtain. That is 0 in this case. Similarly, here 0 in this case. But these two are not differential equation, as there is no derivative involved. Similarly, here when we talk about general and particular solution of a differential equation, first of all, I should have a derivative in the given differential. I mean to say, in the given equation, I should have derivative, and then we talk about the solution. Now, see carefully. Let us try to understand. If I have got any derivative, for example, first derivative I have got. Okay, first derivative in general. Now, actually, what we are trying to do, we are trying to find a dependent value or dependent function y such a way that it is going to satisfy this differential equation. Here presently I have taken first order to make the things clear. Okay, I want such a function y, let us suppose it is some capital F of x, such a way that if I am going to substitute in equation number 1 in this case, that is differential equation, in this differential equation, it should satisfy. It should satisfy. And I want to find that unknown value, unknown function y, the dependent variable. So here y is unknown. Unknown dependent variable. To be specific, dependent variable. I want to know what is that value. Okay. Now we are going to have the method to get this, but first let us try to understand what are the two different solutions we have got. Okay. Now this will be our solution. Okay. And we are thinking to find this. Now coming to this, we have got two categories, and whatever we are getting here, we call either this as solution curve. Solution curve, the word curve, don't forget in differentiation we have discussed, if y equal to f of x represents the curve, then the first derivative stands for slope of the tangent. So actually we have got slope of the tangent, and as soon as I'm going to integrate, I'm going to get back what? Solution curve. The curve which we are talking about, we call as solution curve, or the other name, integral curve. Integral curve. Okay. Now, having understood this, let us try to have the two types under discussion. When I say solution, of differential equation, we have got two categories under this. One is general solution. Other is particular solution. Now, what is this general solution or particular solution? First of all, since the word solution is there, whatever solution I'm talking here, it should satisfy the given differential equation. And now, it need not be this differential equation, any equation involving derivative. Okay. Now, from here, I just want to go in general for any differential equation. Okay. Now, see carefully. When I want to talk about, okay, and here whatever we have spoken here, this is also in general. Okay. Need not be only for first derivative. Now coming to general solution, any solution which contains what? Which contains arbitrary constants. Some alphabets like A is there, some B is there in the solution. Those are not fixed constant. Then we call it is general solution because we have got arbitrary constant. Now coming to this particular solution, any solution free from what? Arbitrary constant is known as particular solution. Now when I'm saying free from arbitrary constant, it also means that whatever we have got a general constant, no, for that we are giving a particular value and obtaining what? A particular solution. Okay. Now let us take one example to be very clear. For example, let us suppose now we have got one differential equation, second derivative plus y is equal to 0. So let us suppose the solution of this is y is equal to a cos x plus b sin x. Is it a solution? Just check it out. If I find the first derivative of this, we are going to have minus a. See, I want to know whether this, whatever the example I have given, y equal to a cos x plus b sin x, whether it's a solution of this second order differential equation. So what am I doing? I'm just trying to substitute here. And to substitute here, you can see I want second derivative plus y. Why I have assumed this presently without solving, I have just taken. So I just want to cross check. Now how are you going to cross check? Find the second derivative and substitute in equation number 1 here. So if I differentiate this, I will get by scalar rule minus here out. Then cos will be minus sign, so minus out here, then plus b cos x. Again, if I differentiate for the second time, we have minus a, sine will be cos x by applying scalar rule, then minus b sine, sine x. Now from here, if I just transpose everything here, we are going to have second derivative, this entire term transpose to the right hand side. Reason, I want 0 in the right hand side, so I'm transferring the entire term to the left hand side. So we are going to have this. Now see very clearly, this entire thing is nothing but this equation number 2 y, correct? So second derivative plus y is equal to 0. Now this is a general solution. General solution I will just write as GS. Okay. So general solution. Why it is general solution? Why not only solution? See, in this first, it's every general solution and particular solution are solution of the differential equation as to satisfying. But in this, we have got a category general solution, particular solution. Reason to make us aware whether we have an arbitrary constant or no. Now, since we have got arbitrary constants A and B, therefore this solution is general solution. Now, let us suppose the same, the same question I will take. And I will just fix A and B value. Let I erase this side. I hope you have made a note. Okay. See carefully now. See carefully. If I take the same, this is example number 1 will take. Now the same example number 1, I am rewriting again here. And now this solution, I will give a particular value for A and B, some random value, let's say 3 for A, and for B I have taken some minus 4. I am purposefully incorporating negative value also. Okay. Now see here, I want to know whether it's a solution or not. So for that I want second derivative, differentiate for the first time. So first derivative is equal to applying scalar rule 3 as it is, sine will be cos, derivative of sin is cos, then minus 4, derivative of cos is what? Minus sin x. Again, since I have got the second derivative, again if I differentiate for the second time, so second that is equal to 3 times of cos derivative will be minus sin, so I'll take minus here, then sin, then minus is plus 4, derivative of sin x is what? Cos x. As you can see, right hand side is 0, so I can transpose all the time to the left hand side. Second derivative is equal to plus, I mean to say, second derivative for a while, since I'm transposing to the which side? Left hand side, we are going to have second derivative plus 3 sin x, then minus 4 cos x is equal to 0. Second derivative, I think this is not looking so good. Okay, now I'll write. Yeah, now it is better. Now this entire expression from this equation number, like give some other number 2. So see carefully, this entire thing is here, nothing but plus y is equal to 0. Yes, it is same as the given question, therefore this is a solution. But now since we have got a particular constant, therefore this is particular solution. PS I will write in short, okay? If there is no such, okay, general solution, particular solution, in short I have taken as GS and PS respectively. So I hope this thing is clear. Now one thing you have to understand carefully, what? How many arbitrary constant do we have in the simplest form for this solution? 2 arbitrary constant. Can you see the order here? Order is 2. Nothing but number of arbitrary constant will decide the order of the differential equation. Since we have 2 arbitrary constant, we have, I repeat, since we have got 2 arbitrary constant, the order is 2. Whereas coming to particular solution will not decide the order of the differential equation. Just I have to have such a differential equation that can satisfy this particular solution. If it is satisfying, yes, this will be a solution for differential equation. If it is not satisfying, it's not a solution of the given differential equation. Same thing holds here. Now let us just try to make still more clear regarding this number of arbitrary constant. Okay, that number of arbitrary constant will decide the order of the differential equation, how it is. So let us take 3 examples on this. Okay, kindly make a note. So dear students, let us take some of the general solution. Okay, first I'll take particular solution. Just see carefully. 3 examples I'll be taking, and all the 3 examples represent a straight line. See carefully. The first example is y equal to x. We know this is a line passing through an origin. This is the graph. A line passing through the origin. Now I want the differential equation of this. To get differential equation, first differentiate the given question with respect to x. Derivative of y with respect to x is dy by dx is equal to derivative of x with respect to x is 1. I hope it's recording. Yes, thank God. So this is a differential equation for this particular question, and this is the solution for this, and this is in fact a particular solution. Why particular solution? Free from arbitrary constant. Okay. Now if I take one more example, same, y is equal to mx. So here this is the equation of a line with slope 1, and this is the equation of a line with slope m. M can be any real number. As I take m is equal to 1, if I take m is equal to 1, I get this. That's what we said, no? Free from arbitrary constant. Or I can also say that as soon as I assign a particular value for the arbitrary m, I get what? Particular solution. Okay, that's what the word, no? Particular, and this is what? General. This is the parameter m. It can vary whichever value it wants, surely a real number only. Okay, now again I want what? Differential equation. So for this I'm going to differentiate, as we don't have any derivative here, so it's not a differential equation. So I differentiate with respect to x, derivative of y will be dy by dx is equal to, here we have got a scalar and a variable. I have to apply scalar rule. So m as it is, derivative of x with respect to x is 1, m into 1 is m. So we have got derivative of y with respect to x to be what? M. This is not a differential equation still because we have got a derivative. Sorry, we have got an arbitrary constant. We have to remove the arbitrary constant. Either you can think of differentiating again. As soon as you differentiate again, derivative of m is what? 0. Correct? If I differentiate again, what am I going to get? Derivative of this, I mean to say, sorry. We got m is a constant 0. But don't forget, no, if you have got here, no, to reach back here, you have to integrate twice. Correct? No? As soon as you integrate second derivative, you get first derivative. Again, when you integrate first derivative, you get the given function, the given curve. So it is not the ideal way. So what is the other procedure? See, this is my equation number 1. Let us substitute this. I have to make sure this arbitrary constant should vanish. So in place of m, here I can just substitute this. So I'll get y is equal to, in place of m, first derivative into x. Now you see, this is a differential equation. I hope this point is clear. So we are not recommending this. Now, see, again, y is equal to mx plus c. How many arbitrary constants do we have? 2. Here, how many arbitrary constants we had? 1. So, number of arbitrary constants, as I mentioned here, number of arbitrary constants. Let us write it here. Number of arbitrary constant is 1, and you see the order also, and order of differential equation is also 1. You can see from here, because the highest derivative is 1. I mean, yeah, highest derivative is of first order, therefore order is 1. Okay. Now coming to this, I'll take this as equation number 2. Now if I differentiate this with respect to x, here we have two arbitrary constants m and c. This again represent a line, slope m, but y-intercept is c. So nothing but the line need not pass through the origin. Okay. So now if I differentiate this, now I have to apply some rule here, and for this I have to apply scalar rule. M as it is, derivative of x with respect to x is 1, c is a constant, so 0. So derivative of y with respect to x is equal to m into 1 is m plus 0 is m. So again let us differentiate with respect to x. So we will have second derivative is equal to m derivative got 0, 0 we have got. Now see carefully. You may ask, sir, the way you have substituted here m value back here and avoided the second derivative, why you didn't do? Okay, forever, just see. If I put this in equation number 2, m is equal to first derivative. See carefully, y is equal to first derivative into x plus what? C. Again I have got that arbitrary constant c present. Since arbitrary constant c is present, it's not a differential equation. I have to be free from arbitrary constant. So surely here also I have to differentiate again. When I differentiate again, I'll get second order. In place of differentiating here, we have to have to find the first derivative here, then I have to apply product rule here, and then c will be 0 because the derivative of a constant is what? 0. It's better to differentiate from here to here itself. And here you see we have got second order. Now how many arbitrary constants we had? 2. So let us comment here, note, as a note, we have 2 arbitrary constants, constants, namely, which are those? M and C. And when I'm writing m and c, since we have got 2 arbitrary constants, that is m and c, order is also 2, and hence order of differential equation is So in short, you can say, highest derivative is, the derivative is here, second order derivative we have got, and hence the order is 2. What is order? Highest derivative, and here the highest derivative is what? 2, second order. So in short, coming to general solution, number of arbitrary constant will decide the order of the differential equation in its simplest form. That's very important. Okay, this whatever we have got now should be in simplest form. Okay, what is that simplest form? Let's try to make you understand here. See, so as we understood that here we have got 2 arbitrary constants, hence the order is 2. See carefully, I'm using one word here, that the number of arbitrary constant, when we are going to go for a count, it should be in simplest form. What's the meaning of that? See this. If I take one example here, let us say fourth one, y is equal to c1 e power x plus c2 plus c3. How many arbitrary constant do we have here? 1, c1. Arbitrary constant, I say, apart from x and y, remaining all the alphabet will be what? Arbitrary constant apart from x and y. So we have c1, c2, c3. We have 3 arbitrary constant, correct? That's what you will think. And we will say order will be what? 3. I think, but the highest derivative will be of third order. Now see carefully, if I simplify this, can't I use law of exponent, and I can write this one as what is a power m plus n? It is a power m into a power n. So this will be e power x into e power c2 plus c3. Now combine these two. See, I can combine these two constants. Why? C1 is one constant, e power c2 is also a constant. Product of two constant is again a constant. So y is equal to a into e power x plus c3, where capital A represent what? C1 into e power c2. Now actually we have got 2 arbitrary constant, which is that a and c3. Since we have 2 arbitrary constant, therefore if I differentiate, my differentiation equation should be of order 2, not 3. That's what I mean in simplest form. Now you see here, you cannot further simplify, you cannot merge m and c into 1 then. Okay, fine. So having understood this, let us move on to the problem. Yes, dear students, having completed the concept on general and particular solution of a differential equation, let us take a problem. But before that, let us make a note what we understood. We understood that number of arbitrary constant, number of arbitrary constants of general solution is equal to order of a differential equation. If the order of the given differential equation is 3, surely the general solution of that should have 3 arbitrary constants. Similarly, if I have a general solution with arbitrary constant 2, its differential equation order should be 2. Okay. Now coming to model question paper number 2 of this academic year. Question says, question number 18, a 1 marker question. Find the number of arbitrary constants in the particular solution of a differential equation of third order is, order is 3, nothing but highest derivative is of order 3, means we have differentiated thrice, and they want arbitrary constant. But for which solution? Particular solution. Particular solution will not have any arbitrary constant, therefore the answer will be 0. Number of arbitrary constants will be 0 because it is particular solution. I hope this point is clear. Now moving on to question number 18. The number of arbitrary constant in the general solution of differential equation of third order. Just see both the question, both are same. Only thing is here particular solution word is used, and here they have used general solution. General solution, as I just gave a note here, number of arbitrary constants of general solution is equal to order of the differential equation. Now since here we said order is 3, we should have 3 arbitrary constant in the general solution. I hope this is very clear. Kindly make a note. Again, this is the 1 marker question. Yes. Yes, dear students, now time has come to learn how are we going to find the general solution or particular solution of the given differential equation. So now let us try to learn the methods. So methods of solving first order, first degree differential equations. So we are going to discuss the method. Now here we have specified 2 things here. First order, so the highest derivative is 1, and first degree, the power of that is also 1. So what are the methods? We have got totally 3 methods. The first method is differential equation with variable separable method. So understand here, variable separable. We are going to separate the variable, separate. What variable? We have 2 variables. Which are those? X and y. Where x is independent variable, y is dependent variable. Let us say that we have got a differential equation of this form. Derivative of y with respect to x is equal to f of x comma y. Okay. Now I want to find the solution of this. Okay, let's have small f. Usually capital F we are taking for antiderivative, so let's not have a confusion. So what we are going to do, first you see this. Here the order is 1, degree is also 1. That's what we're saying now. First order, first degree throughout our PUC. This is what we are going to have only for first order and first degree. Now, what we are going to do, we are trying to express the right hand side as a product of 2 functions, a function having only x and a function having only y. See, f of x comma y means what? F is a function containing x also, y also. Constant is always there. Okay, whether we say or not, constant is always there. Now here, coming to g of x and h of y, it means I am able to simplify this, and we are having a function g containing only x and a function h containing only y. When I said here constant, I mean to say a particular constant. Okay. Now, what we are going to do, we are just going to separate the variable. See, whenever we had an integration chapter, no, integrate, we had here dx, nothing but it's the numerator. I mean to say, it's not there like something like this, integration of some function with respect to 1 by x. No, with respect to x it is, correct? No. So 1 by dx is nowhere there. So when I want to integrate, the dx or dy term should be numerator. So this dx will cross multiply, and this h of y here. So we are going to have 1 divided by h of y dy is equal to g of x dx. Try to understand here. I have all the x terms with dx. We have all the y terms, h of y with y. Now we are going to integrate. So on integrating. Now here we are not going to specify with respect to what we are integrating, because dy and dx is there. That itself says with respect to what it want to get integrated. So here integration of 1 divided by h of y with respect to y is equal to integral of g of x with respect to x. Now integration of 1 by h of y, let us assume it is capital H of y, and integration of g of x with respect to x, let us suppose that it is capital G of x plus the arbitrary constant c. Okay, so where we are assuming that capital H of y and capital G of x are antiderivative of what? Antiderivative. See this. I have taken h of y for small h of y and capital G of x for small g of x. So this is antiderivative of 1 by h of y and g of x respectively. Try to understand this, what I'm writing here. We are assuming that integration of 1 by h of y is capital H of y and integration of g of x is capital G of x, nothing but those are the antiderivative. This is same as when we started our integration chapter, indefinite integral of f of x with respect to x we took as capital F of x plus c, where capital F of x is antiderivative of a small f of x. On the same line we have went, and surely you'll be thinking, sir, when you have integrated here, you should have one constant c, here also one more constant c, but we have done only one constant. How come? No, what about the one more constant? For you to have a clarity, it will be like this. See carefully. Integration of this will be h of y plus some c1 is equal to integration of this is capital G of x plus c2. Now I can transpose this, then we will have h of y is equal to g of x is equal plus c2 minus c1, and we are assuming the c2 minus c1 as capital C. That's what we have got here. So in the chapter indefinite integral also we suggested, we already commented that always for a given problem we are going to have only one arbitrary constant. Even if you have more than one arbitrary constant, surely addition or subtraction of two constant or more than two constant will be a single constant. Okay, I hope this is clear. Now time for the problem. Okay, just I gave this explanation for your better clarity. Okay, so kindly make a note. Dear students, now let us move on to the problem on this method, that is variable separable method. I have written the concept as it is for better clarity. See here, find the general solution of the differential equation. First thing is how to know that, sir, question is from differential equation, what is given, and you can see only differential equation is given, and I have to find what general solution, nothing but I have to find the integral curve or solution curve, correct? No, nothing but this function. I want such a function y that on substitution here it should satisfy, correct? Now we are learning the methods. Now coming to the given question, let us copy the question again. See here carefully. You are going to apply variable separable method as per the concept. X term should be there with dx, y term should be there with y. So see here, dy is here. So y square is here, so cross multiply y square. And dx, the x term is here, so dx this side. So we are going to have y square into this will be y square dy is equal to 2x into dx. We have just cross multiplied. Now on integrating, don't write with respect to x nor y, it's already here. Okay, it is self-explanatory. So now let us draw a line here. So now see carefully, we are going to have integration of y square with respect to y is equal to integration of 2x with respect to x. Recall the formula. Indefinite integral formulas are required here. What is integration of x power n with respect to x? It is x power n plus 1 divided by n plus 1 plus c, where n is not equal to minus 1. So in place of n, see, in place of n, here we have 1. So 2 as it is, scalar root 2 out. This will be x power 1. 1 n in place of n we have 1. 1 plus 1, 2 divided by 2 plus c here, and coming this. See, since we have x, that's in terms of x with respect to x here. Here it is with respect to y. Okay, with respect to y power 2. So in place of n we have what? 2. So just substitute here y. Since x with respect to x, so all in terms of x, but now it is with respect to y and I want to integrate y square. So n is 2. Put here 2 plus 1, 3 divided by again 3. We have got the solution. Just let us simplify. 2 and half will get cancelled as that equal bit bigger. So continuing here, the final comment. Let us simplify. Integration is done. Just simplification. So I can just rewrite what is what we have got. Y cube by 3 is equal to x square plus some constant c1, let us take. Now let us solve for y cube. So multiply by 3 on both the sides. We are going to have y cube is equal to 3x square plus 3c1, or y cube is equal to 3x square plus capital C, where capital C is what? 3c1. I hope this is clear. This is comma, mind it. And this is 1. Okay. So this will be the general solution. And how to know answer is correct or not? You can just differentiate and put dy by dx value here, and you are going to get that back this only. Okay. Fine. Kindly make a note. Okay, dear students, now let us move on to the next problem from model question paper number 2. Find the general solution of the differential equation. Derivative of y with respect to x is equal to x plus 1 divided by 2 minus y. And here they have mentioned y is not equal to 2. It's obvious. If I put y is 2 here, y equal to 2 here, 2 minus 2 will be 0. Number by 0. If denominator 0 is what? It will be undefined. So it should not be equal to 2. Now let us take the solution of this. Derivative of y with respect to x is equal to x plus 1 divided by 2 minus y. Now again we are going to go for variable separable method and see how to know. So I can go ahead. If you are able to segregate x and y separately, I mean to say dx multiple should be only x term or a constant, dy multiple should be either a constant or a y terms. Only then this method is applicable. And you can see presently it is the same type. And when we go for the next now, you will come to know that what if I'm not able to separate, then the next two methods. Okay, homogeneous and linear differential equation. Now just see this. 2 minus y I can cross multiply here, and dx I can cross multiply here. So we are going to have 2 minus y into dy is equal to x plus 1 into dx. Now on integrating, we are going to have integral of 2 minus y with respect to y is equal to integral of x plus 1 with respect to x. Okay, now let us continue with this, dear students. So here you can see minus, so I have to apply difference rule. So nothing but I'll take integration for 2 as well as y. So I'll get integration of 2 dy minus integration of y dy. Don't write equal here, already equality is there here. You can write implies if you want, otherwise keep quiet. Then integral of x dx means x with respect to x plus integral of 1 with respect to x. Now from here, let us recall the formulas. What are they? The formula is integration of x power n with respect to x is x power n plus 1 divided by n plus 1 plus c, where n is not equal to minus 1. Okay, now here, be careful, you have to apply scalar rule. What is integration of k with respect to x? It is kx plus c. So let us go one by one. Implies. Okay. So integration of 2 with respect to y. Integration of k with respect to x is kx. So integration of 2 with respect to y will be 2y. Then minus. For this, I have to apply this formula, x power n with respect to x. Here it is y power 1 with respect to y. So behind y power 1 plus 1 is 2 divided by 2 is equal to integration of x with respect to x will be, again in place of here power of x is 1. So here also 1. 1 plus 1 is 2. So x power 2 by 2. Then plus, okay, plus what is integration of 1 with respect to x? It is x plus c. So integration of 1 with respect to x is what? x plus c. So for all this only one constant c. Don't be thinking no, sir, for this formula, for this formula, for this formula, when you're applying for each you should have one constant. Yes, c1 plus c2 plus c3 plus c4 all together after simplification we have taken as capital C. In short, only one constant. And again you can see order of the differential equation is 1. Therefore, number of arbitrary constants C should be only 1. Okay. Now on simplification we can just multiply by 2 to remove this half. So multiply by 2 on both the sides. Then what will get? 2 into 2 will be 4, y is minus 2 and half will get cancelled, get y square is equal to 2 and half will get cancelled, so x square plus 2x plus 2, I will take the c1. Okay, so 2c1, and again we can assume this will be capital C. So 4y minus y square is equal to x square plus 2x plus capital C, where capital C is equal to 2c1. That's it. Kindly make a note. And this all are what? General solution. Why it is general solution? Why it is general solution? As you can see, we have an arbitrary constant C here. So this is what is general solution. General solution. Now we'll take a problem where we can find how to, we'll understand how to find particular solution from general solution that they have given in model question paper number 3. Kindly make a note of this. And again, this is a 2-marker question. Dear students, we are with the last problem on variable separable method. I repeat, variable separable method. And this is from model question paper number 3. Question says, find the equation of the curve. See the way they ask him. Find the equation of the curve passing to the point 1, 1, whose differential equation is this. X into dy is equal to 2x square plus 1 into dx. This we call differentials. Okay, differential coefficient. Now see carefully. Here, no, surely the word differential equation will point that it is this chapter. Another thing is they are using a word, find the equation of the curve. That's what we discussed now at the beginning. That whatever the differential equation is given, when we integrate, we get either solution curve, the curve name is solution curve, or integral curve. And it's a 2-marker question here. See carefully. Here one extra point is given. The curve is passing to this point. So this point is given so that we can find particular solution. So whatever method we are following so far, same method, just see carefully. X dy is equal to dx square plus 1 into dx. dy multiple is x. As we know, dy multiple should be what? Y only, and dx multiple should be only x. We don't have any problem with 2x square plus 1 because its multiple is dx and we want x term only with a constant, no problem. But this is a problem, so we will cross multiply. That's what the variable separable method. So dy is equal to 2x square plus 1 whole divided by x into dx. Now see carefully this. Can't I separate them? I mean to say, this x want to divide 2x square and 1. So we can write 2x square by x plus 1 by x dx. One x term will get cancelled here. So we are going to have dy is equal to 2x plus 1 by x dx. Now on integrating, see carefully, this will be integration of 1, I can say, because multiple, there is no multiple, but 1 it is equal to integral of 2x plus 1 by x with respect to x. Now again recalling the formula, what is integration of 1 with respect to x? It is x plus c. And again integration of x power n with respect to x is x power n plus 1 divided by n plus 1 plus c. this n plus 1 is the power of x, where n should not be equal to minus 1. Then 1 by x. What is integration of 1 by x with respect to x? It is log of mod x plus c. I have written all the formulas. So one thing is very clear: to dominate this chapter, we should be having the knowledge of integration formulas. At least try to learn this formula, at least to solve these 3 problems. Okay. Now let us proceed. So I want to integrate the solution from here. Integration of 1 with respect to x is x plus c. So integration of 1 with respect to y will be y is equal to, so here scalar take out, integration of x, in place of n we have 1 here, so put here 1 plus 1 2, 1 plus 1 2, so I'll get x power 2 divided by 2 plus integration of 1 by x is log mod x plus the arbitrary constant c, and here 2 and half will get cancelled. So we got y is equal to x square plus log of mod x plus c. Let us write this 2 properly. It got cancelled. Okay. Now see, this is general solution. What is this? This is general solution. But what we want find the equation of the curve passing through this. So this is giving the hint of what? Particular solution. Now you will also learn from this problem how to find what? Particular solution. So we will take this equation to be equation number 1, and this curve is passing this point 1 comma 1. As we know that any point lying on a curve should satisfy the equation. So put x is equal to y is equal to, both as what given as 1. So put x is equal to 1 and y is equal to 1 in equation number 1. So we are going to have, in place of y, 1 is equal to, in place of x it is 1, so 1 square plus log of, in place of x what do we have? 1. Okay, then plus see, I didn't wrote the mod here. Here I did wrote the mod because 1 is already positive. Mod of 1 is 1 itself. Now 1 plus 1 square, I repeat, 1 is equal to, okay, 1 is equal to, 1 square is 1. What is log 1? 0. Recall, log 1 is always 0 plus c. On either side we can see 1 will get cancelled. So we are going to have c is equal to 0. Now we said no, free from arbitrary constant, or by assigning a particular value for arbitrary constant we get what? Particular solution. So now we have got a particular value for the arbitrary constant c. So now as soon I'm going to put this c value in equation number 1. Our equation number 1 is y is equal to x square plus log mod x, and c value is 0. So on simplification, y equal to x square plus log of mod x is the particular solution. Particular solution, nothing but the equation of the curve. Okay, so this is our final answer. So with this, all the problems on this method, that is the method by variable separable method, done. Now we'll take homogeneous. Kindly make a note. Dear students, having understood method of solving, that is variable separable method, now let us move on to the next concept, that is homogeneous differential equation. Before I go ahead, let us not forget, presently we are dealing with methods of solving first order, first degree differential equation. Okay, so both the order and the degree both are what? 1. We are dealing with this, and in this regard we have already finished variable separable method. Now one more method we are learning, that is homogeneous differential equation. Now before taking up the problem, before taking up the problem from homogeneous differential equation, let us try to understand what is this homogeneous function. Okay, homogeneous function. When do we say a function is homogeneous? A function f of x comma y is said to be homogeneous if satisfying a condition. This is a function is said to be homogeneous if it satisfies a condition that f of lambda x comma lambda y is equal to lambda power n f of x comma y. If this condition is satisfied the function by the function f, only then we say it is homogeneous, and this is homogeneous of degree n. Whatever power we have got here, that we call degree. Okay, so f of x is said to be homogeneous if satisfy this condition, and the degree will be n. Now let's take some example to understand this. Example number 1, f of x comma y. So it's a function of having two variables. Suppose I got x square minus y square. Now here, as we can see, in place of x and y, you have to replace x by lambda x and y by lambda y. And if you're getting this lambda out with some power, then we say it is homogeneous of degree n. Now you see, in this equation number 1, if I replace x by lambda x and y by lambda y in equation number 1. So our equation number 1, which is f of x comma y is equal to x square minus y square. So see carefully here, f of, in place of x lambda x and in place of y lambda y is equal to, here it will be lambda x whole square minus lambda y the whole square. Now power is for both. By using law of exponent, we know that a into b whole power n is a power n into b power n. So this power can be applied for both. So I'll get lambda power 2 x square minus lambda power, for this also 2 y power 2. As you can see, lambda square is common. So if I take lambda square common, then you'll get x square minus y square. So now here, if you see very carefully, x square minus y square, this is same as equation number 1, which is f of x comma y. So we are going to have lambda power 2 f of x comma y from equation number 1. So left hand side is f of f of x comma y, f of lambda x comma lambda y, I mean to say. So this, whichever the final step we have got, that is this one which I am highlighting here, is exactly obeyed with this. And here in place of n we have got 2 here. Therefore it is a homogeneous of degree 2. Therefore it is a homogeneous of degree 2. Therefore f of x comma y is equal to x square minus y square is a homogeneous of degree 2. Let's take one more example. F of x comma y is equal to, let us suppose we have got x minus y divided by x plus y. Now I want to determine what is this homogeneous, if it is homogeneous, or the degree. So again, since already one is taken here, so I'll do one thing. I'll take this as 2. So now replace x by lambda x and y by lambda y in 2. So 2 will become, very easily we can just be f of lambda x here, then lambda y is equal to lambda x minus lambda y divided by lambda x plus lambda y. As you can see, in the numerator I can take lambda out as common, so remaining is x minus y. Denominator you can see again lambda is common, remaining is x plus y. So I can say that this will be lambda power 0. Either I can say lambda is getting cancelled, or I can apply law of exponents. So both the case lambda power 0, so I'm going to have x minus y divided by x plus y. And if you see very carefully, what we have left with, see carefully, this particular term which is present here is exactly matching with this. From equation number 2 we can say it is f of x comma y. So here we have got lambda power 0 f of x comma y, and the left hand side is f of lambda x comma lambda y. Therefore, we have got a homogeneous of degree 0. Therefore, f of x comma y, which is equal to this one, x minus y divided by x plus y, is a homogeneous of degree 0. Okay. Now, before I go ahead for the one more example, I would like to comment now directly by seeing also you can comment whether what degree this homogeneous function is all about just by seeing also. So for that, listen this short trick carefully. Point number 1. Whenever you have got product of two variables, that is x and y in our case, because it's a function of two variables and it is x and y. So whenever you have got product of two variables, recall from our school days, law of exponent. What is a power m into a power n? It is a power m plus n. And what is a power m divided by a power n? It is a power m minus n. So as you can see, bases are same. Only then you can add the power in the product form, and for division you can subtract it. Now what we are going to do is, whenever it is a product of variable, we are going to treat both x and y what? Same. So I'm talking about what? Short trick. I'm talking about short trick, how we are going to identify it is homogeneous. See, coming to all the papers, if you see, there are no problems on homogeneous differential equation, but surely I'll take at least 2 problems so that we understand the concept well. But for 1 marker, we have been asked many times about checking the homogeneous of the given differential equation. So this short trick will be very helpful. Let us see carefully how to go. Coming to the first problem, again I'm taking here. In no time we can get f of x comma y is equal to x square minus y square. Homo means same. So power should be same. What is power of x? 2. What is power of y? 2. See, as soon as you have got minus or plus, you are not going to apply this 2. Correct? No. This is only for product and division, law of exponents. So here power of x is 2, power of y is 3. Sorry, power of x is 2, power of y is also 2. Therefore, this is homogeneous of degree 2. That's what we got here. Therefore, it is homogeneous of degree 2. Now, if I take one more example, which I have taken here, this one, see carefully. F of x comma y is equal to, what is that? X minus y divided by x plus y. Now, see the numerator. Degree of x is what? 1. Here y is also what? 1. So, see, in between them we have got minus. Both have got same power. So, numerator we have got power to be 1. Keep as it is. Come to denominator. What is power of denominator x? 1. This is also 1. So it is in denominator 1. So this is of this form, correct? No. So when I take into numerator, this 1 will become minus 1. So 1 minus 1 will be 0. Therefore, this is homogeneous of degree 0. Homogeneous of degree what? 0. I hope this point is clear. Okay. Fine. But first we make a note. Yes, dear student, having understood this short trick, let I just try to make you aware, and I can just say precautioned about always know, not that as soon as we have short trick we can think of forgetting the concept. That's what we say, concept cannot be replaced by anyone. As and how the problems becomes the high level. Now just see this. Third question I will take. A function f of x comma y is equal to cos of x minus y. Now I have to check whether it is homogeneous or not. Now if I go with the usual procedure, see, replace what by what? X by lambda x and y by lambda y in 1. So this will become f of lambda x comma lambda y is equal to cos of lambda x minus lambda y. Lambda is common. So since lambda is common, so lambda of x minus y times, and this cos of lambda of, now we have got cos of lambda x minus y. Now whatever you do, you cannot bring lambda out. Don't forget cos theta is not a product of two terms. It's a short form for cosine of angle theta. So kindly understand this importance. So many will think lambda we can take out. No, cosine of theta. First here you see cosine of theta means what? This is actually the meaning of cos is what? Cosine of angle theta. Similarly, this is a short form for cosine of angle lambda of x minus y. So we cannot take out lambda, due to which this particular is never equal to lambda times of f of x comma y. This implies f of x comma y, which is equal to cos of x minus y, is not homogeneous function. Still we are not talking about homogeneous differential equation. So how can you say we have not spoken? Still there is no derivative. Even the previous two problem also there was no derivative, as you can see here. Now this is not a homogeneous function. Surely I know that many will have a doubt. It means as soon cosine comes, it will not be homogeneous. No. Just see this. I'll take one more example for you. F of x comma y is equal to cos of, let us say, y by x. Simple term application here. And this I will take as equation number 2. Now I have to check whether it is homogeneous or not. So what we are going to do? Replace x by lambda x and y by lambda y in equation number 2. So this will become f of lambda x comma lambda y is equal to cos of lambda y divided by lambda x. Now you see this lambda and lambda will get cancelled, due to which we will get cos of y by x, and I can write lambda power 0. Since lambda got cancelled, I can just write lambda power 0 out. And so you can see here lambda power 0, and this is same as f of x comma y. Let's write bit more bigger this. So now we have got it to be a homogeneous of degree 0. This implies f of x comma y is equal to cos of y by x is homogeneous of degree 0. Now what I want to highlight here is it is not something like as soon you have a trigonometric function, it is not homogeneous. It can be homogeneous. But coming to short trick, this trick cannot be applied as soon you see here. No, see here you may think like this now. Oh, here 1, here 1. So it is homogeneous. And here you will think as 1 by 1. If I apply law of exponent, 1 minus 1 is 0. Here you are escaping, but here you are not. Here thinking that here this is also 1, this is also 1, so it is homogeneous. I mean the power of x and y both are 1, therefore it is homogeneous. So here we are going to stuck. That's the reason I would suggest this trick you only apply if you don't have trigonometric function, log function and exponential function is not involved. Or in short, this is only good for polynomials. Okay, this short trick is only for polynomials. That's what I would suggest. For trigonometry, always the standard procedure is there. So here also we can understand, no, trick, the short trick may fail, but concept will never fail. Okay, kindly make a note. Now let us try to understand homogeneous differential equation. So you are learning method now. Second method I write here, method 2. Last one was method 1. So here homogeneous. Last one was variable separable method. Okay. Now here homogeneous differential equation. Now if I have got any first order differential equation of this form, this differential equation is said to be homogeneous differential equation if the function which is present here, that is f of x comma y, is of degree 0. F of x is, again as understood, is homogeneous. Better that I will specify here. That will be better, I think. Is a homogeneous function of degree 0. For example, see here, the same example I'll take what I just took. I just went here power 1, power 1, power 1, power 1, 1 minus 1, 0. So this will be a homogeneous of degree 0. Okay, degree should mean 0. Only then it is homogeneous. If degree is not 0, then it's not a homogeneous differential equation. Okay. Now we are going to have a particular rule for evaluating this. So let us suppose that in this type 1 under homogeneous differential equation, henceforth I'll be calling this as HDE. Okay, there is no standard notation as such, only in our class HDE. Okay, homogeneous differential equation. Let us suppose that we have been given the homogeneous differential equation of this form, and after evaluating and after simplifying, I got this one in the form of g of y by x. This is my equation number 1. So what will be the procedure is, we are going to substitute the working rule for this will be, so working rule, I will give the heading here, working rule, okay, for this homogeneous differential equation. So put y by x is equal to some u, and if you cross multiply, you will get y is equal to u into x. Now if I differentiate this with respect to x, coming to this part, derivative of y with respect to x will be derivative of y dy by dx. And be careful, since u is taking care of both y and x, so u is also a variable but dependent variable. So u is a function of both x and y. So now see carefully. Now when I'm going to differentiate this, we are going to have product rule here. So this I'll take as first function, this I'll take as second function. Here derivative of u will be u dash, then keep x as it is, plus keep u as it is, derivative of x is what? 1. So derivative of y with respect to x will be x into u dash plus u. This I will take as equation number 2. Now as soon you are going to substitute equation number 2, okay, let's take this also. Equation number 2 here, and this is equation number 3. So as soon as I'm going to substitute 2 and 3 back in 1, the equation number 1 will reduce to variable separable method, and we know how to solve as we have learned previously. But it will be a variable separable method in terms of u and x, as you can see here. No, see this. As soon as I put equation number 2 and 3 back in 1, in place of this highlight, so this entire term will change to derivative of u with respect to x is what? X into u dash plus u is equal to, I'll be in some other function in terms of y by x will be u. So I'll get a function in terms of some other function. I suppose h I will use here. So here we are going to have a differential equation, and here we are going to solve this one by variable separable method in terms of x and u. Last one was x and y. So, and equation number 4. Equation number 4 will be solved by variable separable method. In terms of u and x. This is one form. Okay, kindly make it out. Now dear students, let us move on to type 2 also. See, coming to type 2, the working rule, okay, as soon as I have got differential equation, of the form dy by dx is equal to f of x comma y. No. After simplification, we are going to get this one to be derivative of x with respect to y is equal to h of x by y. So we are going to have this. So this is my type 2. Okay, so both are starting from the same, but on simplification, this is derivative of y with respect to x. So you can see y by x. Whereas here I'll be getting in the form of x by y. So I'm going to write derivative as derivative of x with respect to y. So here y will be independent variable, x will be dependent variable. Whereas here y is y is dependent variable and x is independent variable. So working rule to solve. Okay, let's solve when I say finding the function. So see here, we are going to substitute this x by y, some other variable v. Now if I cross multiply, also I'll get x is equal to y into v. So this is my equation number 1. This is my equation number 2. So again, I'm going to differentiate. See, you can see it's with respect to y. So we are going to differentiate here with respect to y. This will be derivative of x with respect to y is equal to, again, keep y as it is. Derivative of v will be what? V dash plus, then again, derivative of y will be 1 into v. Be careful, v is taking care of both x and y. So it's a function of containing both the x and y. Okay, it's a dependent variable. So now here, derivative of x with respect to y is equal to y into v dash plus 1 into v will be v. Now this we will consider. This is our equation number 3. So put 2 and 3 back in 1. As soon as I put in 1, you can see the derivative of x with respect to y, that is here, will be y v dash plus v is equal to, I'll have some other function, I suppose L. Okay, h I have already used again, there's no problem. I've taken as a different concept here. So L of, I'm going to have a function containing what? Y and v. So for this, let's suppose the equation number is 4. Okay, equation number 4 will be solved by what? Variable separable method. Variable separable method in terms of y and v. Now one question will come definitely, how come sir suddenly it will reduce to variable separable method? One doubt will come. Very simple. See the way we have done for substitution. Here x is replaced by y into v, product of two variables. Here also y is replaced by u into x, product of two variables. Since our substitution is what? Product of two variables. So surely what? It is going to reduce to variable separable. I think what we are going to have in this particular step. After simplification, you can see that there will be a product of x and y. As soon as the product of x and y, I mean to say x and u here, and here v and y, then surely we can think of simplifying and have dx multiple, in this particular case dx multiple to be x term and d u term is here no, let I highlight. So dear students, let us take from exercise 9.4, problem on homogeneous differential equation. Question number 2, derivative of y is equal to x plus y divided by x. I am not going for checking homogeneous. As I said, if it's a polynomial, we can think just by, or I guess a rational function in terms of two variables, we can just think of short trick. Power of x is 1, here also y is 1. So since we have a plus here, don't apply law of exponents, and we can't apply also. Hence here powers are same, and here also power is 1. So 1 minus 1 is what? 0. Therefore it's homogeneous of degree 0. Hence it's a homogeneous differential equation. Now what's the procedure for this? Put y is equal to u into x. Okay, and here we have to differentiate this with respect to x. So we are going to have this one to be y dash is equal to u as it is, x will be 1, product rule. Here this is my first function, this is our second function. So by using product we are doing equaling, no? Yeah. Then u, okay, u as it is, derivative of x is 1. Then keep x as it is, derivative of u will be u dash. u into 1 will be u, so I can write like this: derivative of y with respect to x is equal to u plus x into derivative of u with respect to x. This is our equation number 3. Now put equation number 2 and 3 back in 1. So equation number 1, what is there in equation number 1? Derivative of y with respect to x is u plus x into derivative of u with respect to x is equal to x plus, in place of this y, it is y is what? U into x divided by x as it is. In the numerator, what is common? X is common. So remaining will be, here x is common, remaining is 1 plus u divided by x. Without any difficulty, I can say x by x will get cancelled. So we are going to have left with the u plus x into derivative of u with respect to x is equal to 1 plus u. On either side, you can see u will get cancelled. So we are left with x into derivative of u with respect to x is equal to 1. I can cross multiply. As I said, no, after we simplify, it will reduce to variable separate method in terms of u and x. So you can see now, du is there, so it should be a u multiple. There's no u here, no problem. Dx is there, cross multiply. So you'll get du is equal to 1 by x dx. Now here on integrating both the sides, what we are going to have, integration of 1 with respect to u is equal to integration of 1 by x with respect to x. Integration of 1 with respect to x is x plus c. So I can see, since it is with respect to x, it is x here. Here it is with respect to u, so it will be u is equal to integration of 1 by x is log mod x plus c. But what is u? Come here. What is u? Solve for u here. U is equal to y by x. Don't forget, our question was in terms of what? X and y. So our solution should be also in terms of x and y itself. Let's say equation n. So from equation n, u is what? U by means y by x is equal to log of mod x plus c. So this is from n. Now cross multiply, we get y is equal to x is cross multiplied here. So I get x into log of mod x plus c into x. This is our general solution. Yes, kindly make a note. Dear students, continuing with method of solving first degree differential equation, let's move on to linear differential equation. This will be our last concept, and from this 5-marker questions are assured. So let's first learn the method. What the procedure says. Let us suppose we have got a linear differential equation. So when you say linear differential equation, the highest power of the derivative should be 1. Okay. Now just see this. The differential of this form, derivative of y with respect to x plus p into y is equal to q, where both this p and q are constants or functions of x alone. It's a function of x alone. Okay. Next step. How are we going to integrate? First, the working rule here for this. Make a note. Okay. So the working rule for this will be, first we are going to find the integral factor. In short, we write as IF, which is given as e power integral of this p, that is multiple of y. After making make sure that derivative of y with respect to x multiple should be 1. After you make it 1, then whatever the multiple of y is there, that is p, that we are going to take and integrate. And after finding this, we are going to find the general solution. The general solution is given by, in short, we also write GS. I'll be writing in my class. Okay. y into integral factor is equal to integration of the right hand side into the integral factor. So integral factor into whatever the right hand side we have got. This will give you the general solution. So surely after we integrate, then we are going to give this constant c. Okay, this will be the general solution. So try to learn this. So how we are going to go ahead? As soon as you have got linear differential equation, this will be type 1. Okay, type 1, where we have got derivative of y with respect to x plus py is equal to q, where p and q are functions of x only or a constant. Then the working rule will be, first you will find integral factor, that is e power whatever dy by dx is there, make sure its multiple should be 1. Then y multiple p, integral of p with respect to x, okay, e power the exponential, and then general solution given by y into whatever the integral factor we have got is equal to integral of integral factor into q with respect to x plus c. And since we are going to have some log formula coming into picture, so some note I would like to give. First note is log 1 to the base any base a is always 0. Second note is log, and here e power whatever the function we have got here. So okay, in place of e I would like to say a. So see this, the entire expression log base is a for entire expression, and for log this log the base is also a. So whenever it is happening, then whatever the number is that is your answer, f of x. Then third point will be log m here, k log m will be log m power k. We'll be using all this while solve the problem. Okay. Now what about the type 2? Type 2 under this will be, we are going to have the integral means differential equation of the form derivative of x with respect to y plus p1. See carefully here. Since this was with respect to x and whatever the dependent variable y was there, you had a dependent variable here. So here the dependent variable is x. So p1 x is equal to q1, where p1 and q1 are constants or a function of y alone. Same line whatever we had here. Since it was with respect to x, so p and q were functions of x alone or a constant. Now here it is derivative of x with respect to y. So p1 q1 are a constant or a functions of y alone. Then what will be the working rule for this? How are we going to get the solution? The working rule, first we are going to find integral factor. So the first step will be on integral factor. Let us write here as 1. The first thing is integral factor, then is the general solution. Okay, here also first will be the integral factor. In short we write as if. It will be e power integral of, after making dx by dy multiple 1. So whatever x multiple is there, it is p1. So p1 with respect to y. Second one is general solution. Now coming to general solution, which we call in short GS, is given by, now here the dependent variable is x. So x into integral factor is equal to integral of integral factor into q1 with respect to y plus c will be the general solution. So now with this we are ready for the problems. Kindly make a note. Okay, dear students, now let us start with the 5 marker. I've taken the first question from model question paper number 2. Okay, and as you're aware, it's a 5 marker question from this academic year 25-26, issued by KSEAB board. Now see this question says find the general solution of the differential equation. So coming to the solution of this, as you can see, the linear differential equation. So if I compare the given question with derivative of y with respect to x plus py is equal to q. Okay, is equal to, write q properly, q. So this is our given question, which I will take as equation number 1, and standard form will take as equation number 2. Now on comparing, dy by dx multiple is 1, y multiple is p. So y multiple here it is cot x. So p is equal to cot x, and q is 4x into cosecant x. Let us recall the rule. How we are going to solve? First, we are going to find integral factor. So, what is integral factor here? Integral factor. What is integral factor? I think a factor which is given so that the given differential equation can be integrated. And many times integral factor also comes for 1 mark. Okay. So make sure remember how to find integral factor. It is e power integral of p with respect to x. So e power integral of p is cot x. What is integration of cot x with respect to x? It will be e power integration of cot x is log of mod sin x. Recall what is a power log of f of x to the base a. While giving the working rule, I give this formula, 3 formulas I give, thinking about this only. So whenever the log base, that is a, and the entire expression base a, both are same, the answer is whatever present here, that's your answer, that is f of x. You can see here, for this the entire expression base is e, and here whenever you want to write any base, it's understood that it is e. So these two are same, therefore we are going to get sin x. So as soon as I remove from log, only sin x is enough. No need to mention mod. Mod was mentioned here because log is defined only for the positive real numbers. But we know sin is from range of the sin is -1 to close -1 to +1 closed interval. So we have given a mod here. So having got integral factor here, now let us proceed on general solution. So the general solution is given by y into integral factor of, okay, integral factor, then again integral of integral factor into q into dx. Now what is integral factor? We have got sin x. So y into sin x is equal to integral of again sin x. Then we have q. What is the function q here? 4x cosecant x. So 4 times of x cosecant x. Don't forget both sine and cosecant are reciprocal of each other. So both will get cancelled. So remaining is what? 4x. So now applying which rule? Scalar rule. I can take 4 out. Then I have to integrate only x with respect to x. Recall the formula. What is integration of x power n with respect to x? It is x power n plus 1 divided by n plus 1 plus c, where n is not equal to -1. So in place of n we have 1 here. So substitute here 4 times of x power 1 plus 1 is 2 divided by 2 plus c, 2 1s are 2 2s are. So this is y into sin x. Okay, or y into sin x is equal to 2x square plus c, or I can divide throughout by sin x. If I divide throughout by sin x on both the sides, we get y sin x by sin x plus equal to plus 2x square divided by sin x plus c divided by sin x. Here without any problem, sin x plus x will get cancelled. We are going to have y is equal to 2x square. 1 by sin will be cosecant x plus c into, again 1 by sin is what? Cosecant x. This will be our general solution. Is general solution. I hope the things are clear. Kindly make a note. Okay. Dear students, now let us move on to the third model paper question. Dear students, now let us move on to model question paper number 3. Question says, again 5 marker, find the general solution of the differential equation x into dy by dx plus 2y is equal to x square into log x. See, if you just see the differential equation which is given to us, if you compare with the standard one, multiple of dy by dx should be always 1, but here we have x. So we don't want this x here. So what we'll do? Divide by x on both the side. If we do so, see carefully, x by x will get cancelled. I'll get dy by dx. Then plus 2 by x into y is equal to x square by x will be x log x. This is our equation number 1. Now this we can compare with the standard form. Equation number 2. See, y multiple is p. Y multiple is 2 by x. So p is equal to 2 by x. Then q. Q is the right hand side x into log x. Just have written everything as it is. Fill in the blank side, we are just completing. Now here integral of e power integral of p. P is 2 by x with respect to x. So I can take 2 out. Then integration of 1 with integration of 1 by x with respect to x. What is integration of 1 by x? It is log mod x and this 2 as it is. Now recall, see, to use this formula, log multiple should be 1. Here log multiple is 2. As you can see, this entire thing is the power of e. Correct? No? E is the power of e. So now we have a property. What is k log m? It is log m power k. So this k can shift to power of m. So this 2 also can shift to power of log. So I will get e power, let's remove this. Integral factor will be is equal to e power log x square. This 2 have went to the power of x. Now since square is there, there is no enough mod. Now this is exactly matching with this base and base of log, and the entire term base both are same. Here it is a, and here the base of log we know it is always e, and it's also e. So my answer will be only x square. So this will be our integral factor. So our integral factor is x square. Now let us proceed to find general solution. So coming to the general solution part, y into integral factor is x square is equal to integral of x square into q. What is q? X into log x. Now we have to simplify this. X square into x will be x cube into log x. So I have to apply integration by parts because we have got product of two different functions. So coming to integration by parts, as you can see, x power 3 is algebraic function and log x is logarithmic function. So if I recall the ILATE rule, ILATE, now just see who's coming first in the word ILATE. First comes L, then comes A from left to right. So log x is first function and algebraic function x cube is second function. Recall integration by parts formula. What the formula said? It is integration of f of x into g of x with respect to x is f of x we took as first function, g of x we took as the second function. Keep the first function as it is, integrate the second function, then minus double integral of second function into derivative of first function. So let us proceed. So keep the first function as it is, integration of second function, double integral of second function and derivative of first function. Now see carefully. So keep the first function limit log x as it is. Then integration of second function, that is x cube with respect to x, minus double integral of second function, that is x cube with respect to x. Then derivative of first function, that is log x with respect to x. What is integration of x power 3? Use the formula integration of x power n with respect to x. It is x power n plus 1 divided by n plus 1 plus c, where n is not equal to minus 1. Correct now? So in place of n we have 3. So what will get? Log x. Then this will be x power 3 plus 1 is 4 divided by 4 minus again x power 3. Only this part when I am going to integrate. Again we'll get x power 4 by 4 log x, that is what, 1 by x with respect to x. Simplification, here x and 1x will get cancelled, x by x, so I will get cube here according to so we are going to have x power 4 by 4 log x minus 1 by 4 out, scalar rule, correct? Then x power 3 with respect to x. So we are going to have x power 4 by 4, here it is 4, log x minus 1 by 4. Integration of x power 3 will be x power 4 by 4 plus c. So the final comment will be left hand side is y into x square is equal to x power 4 by 4 log x minus x power 4 into 1 is x power 4 divided by 4 into 4 is what? 16 plus c is general solution. This will be the general solution. If we want, we can divide by x square as well. This is our general solution. Let us suppose that you want to be very specific and you want to solve for y, nothing but explicit function. Then our final comment will be divide by x square on both the sides. Then we are going to have y is equal to x square got cancelled. Here x power 4 by x square will be x power 2 divided by 4 log x. Then minus again x power 4 by x square will be x square divided by 16. Then plus c. Okay, c divided by x square, to be very specific, is general solution. Okay, with this we completed this problem from model question paper number 3. Okay, 5 marker. Kindly make a note. Dear students, now we are the last problem from model question paper number 1. Again, question is find the general solution of the differential equation derivative of y with respect to x plus 2y is equal to sin x. Now if I compare this with the derivative of y with respect to x plus py is equal to q, on comparing, this is equation number 1, and if I take this as equation number 2, as you can see dy by dx is 1. So on comparing, p multiple of y is p, here y multiple is 2, so p is equal to 2, and coming to q, that is sin x. Just we have compared. Now I want integral factor. So integral factor is given by if is equal to e power integral of p with respect to x. E power integral p is 2 here. What is integration of a scalar? Recall integration of scalar with respect to x is kx plus c. So integration of 2 will be 2x, no plus c. See the order 1. So we should have only one arbitrary constant that will be at the end. Okay, so this will be your integral factor e power 2x. Now let us move on to the general solution. So the general solution is given by, recall the formula, it is y into integral factor is equal to integral of integral factor into q with respect to x. Integral factor we got e power 2x, recording no? Yeah, e power 2x, y into e power 2x is equal to integral of, again integral factor got e power 2x q. What is q? Sin x. So now again we have to apply integration by parts, as we have got product of two function. See, this is e power 2x is exponential function and sin x is trigonometric function. So better we'll do one thing, we'll take this one separately and get the answer, then you can substitute. So let us try to integrate this separately. So consider as and take as I, it will be a little lengthy this integration. So we'll take separately and let us name this 1, 2 already named, so we'll take as 3. So as now we said that this is exponential function, this is trigonometric function. If I go with the word ilate, so you see first comes t from left to right, first comes t, then comes e. So t is the first function, that is nothing but sin x is first function and exponential function is second. Recall integration by parts, which says integration of f of x into g of x with respect to x is f of x is the first function, g of x is the second function. Keep the first function as it is, integrate the second function minus double integral of second function with respect to x into derivative of first function with respect to x. So here it's a first function, then integral of second function, double integral of second, and derivative of first function. So let's proceed. So keep the first function sin x as it is, integration of e power 2x with respect to x minus double integral of e power 2x with respect to x, then derivative of sin x with respect to x. What is integration of e power 2x? E power 2x integration is e power 2x divided by 2 minus, again, what is integration of e power 2x with respect to x? It will be e power 2x divided by 2. Derivative of sin x will be cos x with respect to x. Again, here half, then sin x, e power 2x as it is, then minus half I can take out of the integral. Again, integration of e power 2x into cos x with respect to x. As we know, this is the exponential function, this is trigonometric function. So already we have the same type of function. So this is the second function, this is the first function. Again, I have to apply integration by parts. Kindly make a note. I am going to erase this side. So now let us proceed. So the remaining, that is half sin x e power 2x minus half of. Now for the C, be careful, half is multiplied for the entire term. So whatever the integration I am going to get for the minus half should be multiplied. So again, applying by parts, keep the first function, that is cos x, as it is, integration of second function, that is e power 2x with respect to x, then minus double integral of e power 2x with respect to x, then derivative of the first function, which is cos x here, with respect to x. Okay, now let us proceed one by one, closing the bracket here. So next, half sin x e power 2x minus half cos x as it is, integration of e power 2x is e power 2x divided by 2 minus integral of, again, integration of e power 2x with respect to x will be e power 2x divided by 2. Derivative of cos with respect to x will be minus sin x with respect to x. Now on simplification, half sin x e power 2x. Now just see, minus 1 into cos x will be minus cos x e power 2x. 2 2s are 4 in denominator. Minus into minus is plus, plus into minus is minus. Half into half will be 1 by 4. Integral of e power 2x into sin x with respect to x. Now if you see this term, that is integral of e power 2x sin x with respect to x, is same as what we have already got. Let us say here this is equation number 4. This entire thing is equation number 4. So this will continuously the same will happen, since the derivative of e power x is e power x itself, and integration of sin will be what? Minus cos. Cos will be sin. Again sin will be minus cos. It is going to oscillate between sin and cos only. So it will never end, due to which what we will do is, this one is same as this. So we'll stop here and we'll say minus 1 by 4. This entire thing from equation number 4, it is I. And don't forget left hand side now throughout, since I have taken I here. So left hand side throughout we have what? I. Here also what? I. Here also I. So just continue here. I is equal to, in this you see something is common. E power 2x is common, fine. And half is also common, fine. So remaining will be sin x minus cos x divided by 2. Correct? Half common. So 1 by 2 will be pending from 1 by 4. Okay. Then solve for I. So I can transpose this to the left hand side. So we will have I minus 1 by 4 become plus 1 by 4i is equal to e power 2x divided by 2, and here there is nothing, it means 1. LCM of 1 and 2 will be 2, so 2 by 1 is 2, so 2 into sin x minus 2 by 2 will be 1, 1 into cos x. Okay, now here 4 is the LCM, so I can say I is common here, so here I is common, 4 is LCM, so I'll get 4, nothing is in what, 1, no, so 4 by, so let's go for still more in detail. I is common here, so remaining is what, 1 plus 1 by 4. Okay, is that fine? So now here e power 2x, 2 2s are 4, then here 2 sin x minus cos x. Here the LCM is what now, 4. I think that here there's nothing, 1 and 4, LCM is 4, so I as it is, 4 by 1 is 4, 4 into 1 is 4, plus 4 by 4 is 1, 1 into 1 is 1, is equal to e power 2x divided by 4. Here it is 2 sin x minus cos x. So here 4 by 4 got cancelled. So 4 plus 1 will be 5. So let I erase this side. Kindly make a note. This is a bit lengthy problem. Kindly make a note of this. So erase P. I am retaining equation number 3 as it is, because after getting the answer we have to substitute in equation number 3 itself. That we have a final answer. So let I retain it. So see carefully. So I am continuing it here. So we are going to have 4 plus 1 will be 5. So 5 into I is equal to e power 2x into 2 sin x minus cos x, or cross multiply 5. Therefore, I is equal to e power 2x divided by 5, 2 times of sin x minus cos x. Don't forget what is I. Actually, I, we took this as an expression, correct? No, so I is e power 2x sin x with respect to x is equal to e power 2x divided by 5, 2 sin x minus cos x, put in equation number 3. So our equation number 3 will change to y into e power 2x is equal to this integration answer is here, which I am highlighting. I have put in equation number 3. So we will get e power 2x by 5 times of 2 sin x minus cos x plus c. If at all you want explicit solution, nothing but in terms of y only, means that left hand side should be only y term. So divide by e power 2x on both the sides. So we are going to have y. E power 2x by power 2 will get cancelled. Again also will get cancelled. Get 1 by 5 times of 2 times of sin x minus cos x plus c divided by e power 2x, or y is equal to 1 by 5 times of 2 sin x minus cos x plus c e power minus 2x will be your general solution. This we have taken into numerator. When you take base to numerator, the power sign will change from positive to negative and negative to positive. This is the logic now. What is 1 divided by a power n? It is a power minus n. Okay, kindly make a note. Okay, fine. So see, be careful. After this, it is this step. I have written this one to just substitute back. Okay, kindly make a note. Yes, dear students, with this we complete differential equation. Okay, from PUC part. So make sure study well. Give 100%. Be dedicated towards the studies. Give 100%. Exam is approaching near to you. Okay, all the very best. And pay attention and give your 100% attention, focus to prepare well and excel in your examination for upcoming second PUC board exams. So God bless you all. Lastly, do like, share and subscribe to our YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you all.